So today we are with the team from University of Trieste in the context of the World Bioproduct Day campaign that we conducted together with the World Bioeconomy Forum. They have been selected as winners of the category Innovative Youth. In fact, we really appreciated the fact that in this research project, there is an active involvement of young researchers and PhD. So welcome you all, and can you briefly introduce your research about the valorization of rice husk?
So yes, thank you. We are honored to receive this prize, and we want to confirm that we are a young research group headed by Professor Lucia Gardossi, who inspires us daily to be actively involved in bioeconomy context. Rice husk is an underexploited biomass. It is made by cellulose, lignin, and silica. The annual productivity of rice husk reaches around 120 million tons, but only 20 million tons are used each year. Currently, the rice husk is used like absorbents or additive for construction materials. It's a residue of the rice processing, and rice husk has a very low price, also in Italy. That is the first producer of rice in Europe.
Mm-hmm. And what is the main goal of this research?
Our research group studied the potential of this biomass from several years. We wanted to demonstrate that rice husk it's possible to transform in a very low environmental impact material. During my PhD, we study in depth the structure of rice husk, and we tailored its properties using sustainable chemicals and enzymatic methods. So at the end, we have been successful in giving rice husk useful properties for this biomass.
Mm-hmm. And in this context, what are the added values of these applications, maybe compared to similar ones?
Yes, we study a lot different applications for rice husk. In the first time, we demonstrated that it's possible to transform rice husk in a robust, low-density and renewable material usable as carrier for immobilization of enzymes that are used in industrial process. We developed protocols to obtain a new final bio-based polymers aiming at the recycle and replacing the conventional fossil plastics. And another application that we study is the formulation of these spoons. That is a biocompostable plastic spoons that we can use in our life every day.
And what are the challenges of this experimentation?
Okay, I will ask these questions. The big challenge is to boost the transition from fossil-dependent industry to the fossil-free and circular bioeconomy. The most impact of plastics comes from their fossil raw materials. So for this reason, they have to be left behind. Rice husk allows us to develop biocatalytic processes for polymer synthesis with different functionalities and advanced properties, and they are economically competitive at industrial scale, enabling large-scale application. And the economic and environmental sustainability paved the way for the development of polymers, materials, or products useful for different applications, such as smart packaging or biomedical application.
Okay, thank you for your insights. And as the last questions, I would like also to ask you for an advice to students, because we know that this year is the European Year of Youth, and the aim is to recognize the importance of the European youth to build a better future, greener, more inclusive, but also digital. And from your perspective of young researchers dealing with bioeconomy and sustainability, I would like to ask your advice to young generations also in a post-pandemic perspective.
It's evident that the ecological transition is a goal that must be pursued. So the task for young people must be to accelerate the development of solutions. For this reason, I invite the new generation to build up their future by exploiting the science and the biotechnology, as well as their intellect and creativity. The ecological transition is a goal that must build up, aiming to move away from the use of fossil materials.
Okay, so many thanks for your insights, and we hope to hear again from you and to see how your research will develop in the future.